Okay, all these questions involve rational expressions. This first one, we're supposed to add this. When you take a look, this denominator is similar to this, other than it's backwards. So there's a nice trick that you can use to do that, to change. So you can change it. So let's leave this first one as a cubed over a minus b. And then the next one, you can change that to a minus b only if it's exactly opposite. And you can do that as long as you change this sign right there. So that sign there no longer is a positive, it's a minus. And then we leave the other stuff up top. Then I have a common denominator now, so I can add or subtract the top two, I guess, over a minus b. Now I'm feeling pretty good at that point, but this top I notice is a difference of cubes. So I can rewrite that as a minus b, just following that formula, and that a squared plus ab plus b squared. So that's all over a minus b, and then the two a minus b's will cancel out. So my final answer will be a squared plus ab plus b squared. Okay, that's a good one. Here's another question. We're asked to divide polynomials, so that would be right there. So if I need to divide that, one thing I could do is I could factor that first thing. I think, is that a y cubed or a y squared? Maybe it's a y cubed. If it's a y cubed, I can't factor it. So if it's a y cubed, so I have y cubed minus 3y plus 10. One of the problems is you have to make sure you account for every term. So it's really y cubed plus 0 y squared minus 3y plus 10. So to do synthetic division, I'd have a 1, a 0, a minus 3, and a 10. And dividing, if this is a minus 2, then you use a positive 2, just like you were. Bring down the 1. 1 times 2 is 2. Add 2. 2 times 2 is 4. Negative 3 plus 4 is 1. 1 times 2 is 2. Add, and I get 12. So my remainder there is 12. Okay? And here's another. So there's a dividing one. This one here, it's missing a bunch of terms. So it really should be x cubed plus 0x squared plus 0x minus 8. So you'd have 1, 0, 0, minus 8, and dividing that again by a positive 2, like you had. And then do the same thing, synthetic division. Question is this one here. And they say find all values of x for which f of x has the indicated value. So they're saying f of x is equal to 1. So here's my function. F of x is equal to 2x minus 6 over x. And they're saying wherever you see an f of x, put in a 1. So here's f of x, I'll put a 1 there, is equal to 2x minus 6 over x. Now it's a rational equation, so I can solve it. This is over 1, this is over 1. My lowest common denominator will be x. And so I'm going to take this and times by x, this by x, and this by x. In the first one I get an x is equal to 2x squared minus 6. This is a quadratic, so to solve that, I'll move the x over to this side. So I'll have 0 is equal to 2x squared minus x minus 6. And I could use a quadratic formula to solve that, or I'm going to try and just factor it. So 2x and x, I'm thinking maybe a 3 here and a 2 there. Let's make this one, well, that'd be 6 minus 2. No, that can't be. Let's put a 2 here and a 3 here. So it'd be 2, yeah, that'd be right. So minus and a plus equals 0. I think that's factored correctly. 2x plus 3, so 2x squared minus 4 plus 3. Yeah, that's right. Okay, so now, sort of funny that my finger draws something there. So now that it's factored, now I can solve. So I say 2x plus 3 equals 0, or x minus 2 is equal to 0. And then to finish this one, take the 3 over the other side, make a negative, divide each side by 2. So there's one answer. The other one, x is equal to 2. I always like to check these at this point and take these and put them in the original equation right there, just to make sure that they don't make that equal to 0 on the bottom. And neither of them do, so I would count both of those as answers. Okay, hopefully that's helped.